Hello, everybody. It's the community team here for another demo. June week 3. Yeah. All right. First, we have Larry. He's going to show us update by. Larry, take it.
All right, I'm going to share my screen and let's demonstrate updateBy. updateBy is it's related to our aggregation by operators inside of Deephaven. This is a little interesting in the sense that there's no actual aggregation happening. What it's doing is showing effectively like a summary, like a moving average or a cumulative sum, cumulative minimum or maximum. So first thing I'm going to do is just start a local instance. I'm more comfortable in Groovy, so I'm going to demo this in Groovy today. And when that is up, I can bring us over to the web UI. Okay, and so this is my demo. Can you read the text okay? Do I need to resize it?
Oh, looks good.
Okay. So what I did, I have some canned data that's just kind of looks like some sales data. So I didn't like the way the dates look, so I'm actually picking all the dates, just give me a random date within the last 365 days. So a lot of this first part is just boilerplate. I'm just bringing this random date function where it's visible to the query processor. And then now I'm actually going to go out and read some sales data CSV file. And here's where I'm reintroducing new dates for the data. So execute this. And here's our sales. Let me just pop into it real quick so you can see a little bit of the structure. Key items, this item type is going to be key later. Each order has an item, and then the order date I'm going to be using to do some exponential moving averages over, and then total cost, price, and profit. Keep those in mind. All right. So I wanted to demonstrate this over not just static data, but live ticking data. So I kind of did a little bit of hack where I'm just introducing a timetable that's going to produce 10 rows per second. And it's going to generate an index that's going to basically join itself with the sales data. So if I show this, basically what this is doing is every 10 seconds, it's bringing in the next 10 rows of the original data, but with a higher index, which allows me to execute this merge. So now this timetable is a 2+ million row database that is actually ticking every 10 seconds, or every second we're going to get 10 new rows. What's important right now is these rows are being introduced effectively in random order. So the date, this order date is entirely random with each set of new rows that's coming into the table. All right. So all that has done so far is just set up the data set we're going to use for the updateBy. And here's some of the operators we get to do. And this is I'm going to use the timetable. I'm going to sort by order date. So my cumulative sums are increasing in date order. And my moving average is going to be relative to the previous dates. The first operator I'm going to use is a exponential moving average. I'm going to have it do a time-based one over 14 days. And we'll see we're going to be using the product of this operator is going to be in the column total profit. I'm also going to do a cumulative sum over total profit and then display the minimum and maximum as this goes on. Now, this is a buy operation because I'm actually going to limit this to an effective grouping over the item type. So what that means is this is not over the entire data set, though of course that's possible, but this will actually do an exponential moving average only over the item types that match. So cereal will be batched with cereal. Okay, so let's pop into that thing. And I'm having an error.
Imports.
Yes, thank you. I forgot to run the import statement. Thank you, Devin, for that. So these are useful. I'm bringing in this static import so I can use these without the full qualified name. All right, let's run that again. Okay, and here's our sales summary. And this is now ordered by date because I requested it to be by order. And then we can look at these first couple items. So, okay, so this one and this one, personal care, you can see that these are relative to the item type, but since this row and this row are related, we can see the EMAs are, are close, but being executed properly. Minimum and total profit are displayed. And then the other items are being summed appropriately. But that's a little complicated to see, so I'm just going to restrict this to a single type. And so I just decided to pull out baby food. I'm going to execute this, and I'll spend a little bit more time on this baby food one. So we can kind of see now all of these are of item type baby food, and it's easy to see that the EMA is being calculated with every row, and the accumulated sum is actually accumulating, and the minimum and maximum profit are displayed. What is, I think, pretty interesting is this is still a live table. And so if I go down to the bottom of this, you can actually see that new rows are being introduced, 1,660,000. So there's new rows being introduced every second. And if you look at the final row of the table, you can actually see that this total sum profit, as the new rows are introduced, and they're being introduced in a random date, but this is staying consistent as the rows are introduced. These are newly calculated, and every row that's affected in a cascading effect, for example, for the cumulative sum is being updated. So this final row is showing the cumulative sum for the entire data set of baby food. And the EMA is being calculated all through the table dynamically as new rows come in. They're being inserted the table in any order, and the EMA, the sum, the minimum and maximum are all being recomputed. So that's an overview of what updateBy does right now. We wanted to add some new features like pure windowing, so we can do like a moving average or a rolling sum, rolling minimum, rolling maximum, and have those both date and like row-based operations. But right now it's a pretty impressive new feature.
Awesome. I think Devin is going to show us a little bit related to air quality with some of these features.
That is the plan. Thank you, Larry. I'm really excited about this new operator. And one of the ones I'm most excited about is the EMA updateBy operator. And I will show you a little bit about that right now. Go ahead and share a window here. I'm going to try and motivate it by a use case that I personally have. So I live on the West Coast, and it seems like over the last couple of years, wildfires have been getting worse and worse. We basically have a wildfire season. And one of the things you have to worry about with wildfires, in addition to just the fire, is the air quality. So there's just a couple quick links I'm going to go through here. There's some good resources around the EPA will give you about particulate matters and what these different standards are. PM 2.5, fine inhalable particles that are 2.5 micrometers and smaller. The harmful effects. California puts out some good information. An air quality index around this, what are good numbers and what are hazardous numbers. And so I've got one of these sensors set up at my house, and I've been collecting data for the last couple of days, and I'm going to demonstrate it in Deephaven. To talk about my setup a little bit, I've got a Raspberry Pi hooked up to an Enviro Plus machine, which measures some different environmental stuff. But specifically, I am using what is called the particulate matter sensor 5003. It looks like this, and it sucks in air, and it has some laser scattering, and it gives you some sensor data out. So if we go back into Deephaven, we can go ahead and see this. So this is the live sensor data being streamed in. The sensor updates about once every 2.5 seconds or so. This is part of the raw data. It's not all of the raw data, but for this example, I am just going to show part of it. So here's PM 1.0, PM 2.5, PM 10, and then a raw sensor data right here for particulate matters of 0.3 microns. So essentially, we'll go, you can see that these numbers right here are pretty low, and that means that our air quality is pretty good right now. This P03, we can ignore that for now because that's not a standardized unit. But we can go ahead and look at a graph of it. So here is the graph of it over about the last 3 days. You can see it is pretty noisy. A lot of times the values are 0 or 1 or 2 or 3, and they jump back and forth. So we've got 3 different values here, but they're pretty correlated right now. And so let's just focus on PM 2.5. You can see there was some event right here. I wasn't actually at home at this time, so I don't know what this was. It was just maybe it was a dusty day or something like that, around noon or so. And it's ticking right now. So, this data is useful, but it is kind of hard to take these discrete values, because they're 0 or 1 and they're jumping back and forth. So as soon as we got that updateBy function, I'm like, I will apply an EMA to this. And that's exactly what I did. So here's PM 2.5, the raw data, and I've got some EMAs for 1 minute, 5 minute, and 15 minute. And if we go ahead and display them, maybe it's not the best colors, but if I turn off the initial one, you can see these are much smoother values than we saw before. Obviously, the longer your EMA timeline, the smoother it'll get. So this is a very smooth value because it's EMA over 15 minutes. And if you wanted something that changed a bit more, you go for an EMA of 1 minute. And of course, if you zoomed in to where this event happened right here, we could see, yeah, it has the typical EMA behavior of it's not going to be as fast on the take up or as fast on the drop off, depending on the timelines you used. But when you do use EMAs, it's sometimes a lot easier to deal with. If you're dealing with very noisy sensor data, you might get a lot of false positives, downstream, and so you need to apply some kind of filtering first. And so I'm very excited about using EMAs for air quality sensor data, and just to show you that it's still useful even if you are dealing with values that are high integer values and not just centered around 0. We've got some raw sensor data here that is not a standardized value, but you can see it looks very much like the other sensor data graph. And it's not really close to 0, but it is still very noisy. And so we can still see that we can apply EMAs here and get smooth values out. Again, even though it's not a number that's close to 0. So I think this is a pretty useful functionality. I'm looking for it officially landing.
Done. Next up, we have Stacy showing us an integration with.
Okay. Yeah, let me show my screen. Okay, can you see it?
Yep.
Awesome. So yeah, I want to demo today the integration Deephaven with TensorBoard. Let me start with the little piece of general information. Yeah, you probably already know TensorBoard is a popular visualization tool that can be used when training deep neural networks. TensorBoard can track your experiment metrics like loss, accuracy. It can visualize your model's architecture. You can view your model weights, biases, and so on and so forth. So it's quite powerful tool, and using it with Deephaven IDE is pretty easy, and well, literally requires just a few lines of code. So I want to demonstrate it with the classic iris flower classification problem. So to use TensorBoard with Deephaven, you just need to do 3 steps. The first step is just to set up your log directory. It is the folder where TensorBoard will store its logs. So TensorBoard will read these logs to show various visualization. Then the second step, you just need to specify what information we want to write to TensorBoard logs after each epoch. So you just create a callback object with a bunch of settings and give it to your train function. And yeah, that's it. After that, you the third step, we just need to view all the summary information in the TensorBoard dashboard. So to do this, you just need to run the simple command. Yeah, we can run in terminal, we can run it right here. And yes, you can open the TensorBoard dashboard using the default, using localhost and default port 6006. Yeah, let me show. And yeah, here we can explore the gathered data. So the first tab is the scalar tab here. It shows changes in loss and metrics over the epochs. And you can track any other scalar values if you want. Another tab I found useful is the graphs tab. It shows your model's layers. So here, of course, we have a pretty simple Keras model, but well, anyway, you can use this to check if the architecture of your model looks as intended. You can also check, you can also use TensorBoard to check a distribution of weights, biases. If you use hyperparameters, you can monitor hyperparameters here too. Besides, in my example, I used a TensorFlow model, but you can integrate TensorBoard not only with TensorFlow project, you can use it with PyTorch too. So yeah, hopefully this information might help you to debug your training runs and build better models with Deephaven and TensorBoard. So yeah, I think this brings us to the end of this demo.
Very cool. And that's all we got for this week. So